Let's take a look at this next example where we're going to be interpreting a computer regression output. So let's take a look here. Many people do not believe that students learn better if they sit closer to the front of the classroom. They do learn better if they sit closer to the front. Does sitting closer cause higher achievement, or do better students simply choose to sit in the front? To investigate, an AP statistics teacher randomly assigns students to sit in different locations in his classroom for a particular chapter. At the end of the chapter, he recorded the row number, row 1 is closest to the front, and the test score for each student. A least squares regression was performed on the data, a scatter plot with a regression line added, and a residual plot with some computer output from the regression line is shown below. So here is our regression line. This is the row. This is the score on the test. Okay, here's your residual plot. Remember, it's always your explanatory variable against the residuals. And then down here we have our computer output. Remember, your top row is always your y. Your second row is always your x. So this is your y-intercept, and this is going to be your slope. Remember, we don't deal with this, okay? And then we are just going to take a look at r squared, and s is our standard deviation of our residuals. Let's take a look at some questions based on this information. What is the equation of the least squares regression line that describes the relationship between row number and test scores? Make sure you're defining any variables that you use, and you use y hat here. So let's get our information from here. We know that this, we said, is our y row. This is our x. So coefficient is where we get the equation of our line. This is our y-intercept, and this is going to be our slope. So now we just fill that information into our formula. So our formula is y hat equals 85.706 minus 1.1171x, where y hat, make sure you're including your y hat here, and when you write y hat, make sure you say predicted score, and x is your row number. Let's interpret the slope of the regression line in context. So this is just saying for each additional row from the front of the classroom, the least squares regression line predicts a decrease of 1.1171 points on the student's test score. Notice how we're saying predicting. It's what we're predicting. It's not exact. Let's find the correlation. So remember your correlation, we are never going to use our r squared here, but we can use our regular r squared, not the adjusted. This is your r squared value. So here, okay, here's the tricky part here. When I take the square root of r, I'm going to get 0.217. But just do a quick check. Remember that when we find our slope, it's r times the standard deviation of y over the standard deviation of x. These are both positive, so they're not going to affect the slope of our sign. Since our slope is negative, that means our correlation coefficient must also be negative. So that's not going to give you that. You have to know to add that in. Remember that it shows the direction and the strength. So this is going to tell us that it's a negative slope. The slope is negative, therefore we must include a negative sign with the correlation coefficient r. Is the line an appropriate model to use for this data, and explain how you know. So this is where you're going to want to talk about your residual plot. Remember from our previous page when we looked at the residual plot, there was no obvious leftover pattern in the residual plot, so they were randomly scattered about the line y equals 0. Therefore, it's a good model for the data. Now, the regression to the mean. So using technology is often the most convenient way to find the equation of a least squares regression line. It's also possible to calculate the equation of a least squares regression line using only the means and the standard deviations of the two variables. So remember, you have your equation y hat equals a plus bx. Notice how I can write the equation if I know r and my standard deviation of y and x, because that's where I get my slope from, then I can also find my y-intercept. Well, how can I find the y-intercept? Well, if x bar and y bar are points on the line, I can go ahead and fill them in for y and x and my slope and solve for my y-intercept. Take a look at this information. So in the previous example, we investigated the relationship between test scores and seat location. The mean and standard deviation of the row are following. X bar is 4.033. The standard deviation of x is 1.974. The mean and standard deviation of the test scores, or your y's, are y bar is 81.2 and standard deviation of y is 10.135. The correlation between the row number and test score is R is negative 0.218. Now this is slightly different from the previous example because of the rounding in the computer output, but that's okay. Find the least squares regression line for predicting test score from row number, show your work. Go ahead, try this, hit pause, and when you're ready to see the answer, go ahead and hit play. Did you remember to use your formula sheet for the slope and y-intercept from your AP exam formula sheet? Hopefully you did. So now, just remember our x bar and y bar are on our line. So we knew that R was negative 0.218. We also knew our standard deviation of x, our standard deviation of y, and we know the points x bar and y bar are on the line. So first let's find our slope. Fill in your R, your standard deviation of y, and x that were given to you in the question. Notice we found the slope that is the exact same slope from the computer regression output. Now, how can we find that y-intercept? We know the points x bar and y bar are on the line. So to find the slope, I just filled in what is my y bar, 81.2, minus the slope that I calculated above, and my x bar, which is 4.033, which gives me my y-intercept of 85.71. So notice, you have to find your slope first because we need the slope to find the y-intercept. So you're always going to want to do that first and then fill in your slope and your x bar and y bar into your equation to find the equation. So the predicted test score, make sure you have your hat there, is 85.71 minus 1.119 times the row number.